Students, is the screen visible?
Yes, sir.
Okay, ठीक है. Tell me, problem number 2, which option will be correct?
Option A.
Option A will be correct. Are you sure?
Yes, sir.
Okay, देखो ये A B है. What type of gate it is?
And get
Students,
And
gate 1 is the AND gate. तो output क्या होगा? A dot B. Gate 2 is also AND gate. So इसका output क्या होगा? C dot D. Okay, what is the gate 3? Gate 3 कौन से टाइप का गेट है?
NOR gate.
नॉर गेट ना. अगर ये और गेट होता तो हम क्या लिखते हैं? A डॉट बी, ओके, प्लस क्या लिखा जाता? C डॉट डी. लेकिन ये नॉर गेट है तो हमें इसका कॉम्प्लीमेंट लेना होगा. सो विच ऑप्शन विल बी करेक्ट? आंसर ऑप्शन ए विल बी करेक्ट. आर यू ऑल क्लियर हाउ टू आइडेंटिफाई?
yes, sir.
Yes, sir.
स्टूडेंट्स पक्का? ओके, चलो आई विल गिव यू वन मोर प्रॉब्लम ऑफ द सेम टाइप, so you will gain the confidence in this category. Yes, students. Let's say there are two input lines A and B. Okay. So what you have to do is, let's say this output is Y1, this output is Y2, this is Y3, and this one is Y. So suppose A is equals to B is equals to 1. Then you have to tell me the entries for Y1, Y2, Y3 and Y. Chalo. Just operate and tell me what will be the value of Y1, Y2, Y3 and Y.
Y1 is 0, Y2 and Y3 are 1, and Y is 0.
Okay. Other students? Are you getting the same? No answers. Okay. देखो ये कौन से टाइप का गेट है? अगर ये दोनों भी 1 है और ये भी 1 है, दिस 1 विल बी कैरी फॉरवर्ड हियर, हियर आल्सो. ओके, एंड गेट का आउटपुट क्या रहेगा? इट इज A डॉट B कॉम्प्लीमेंट. तो 1 डॉट 1 इज 1, लेकिन उसका कॉम्प्लीमेंट क्या बनेगा? विल बी 0. So student Y1 will be 0. Accepted? Students, is it accepted? Y1 is 0.
Yes.
What's the issue? Now see, the same input line is connected here. So this is 1. The same input line is connected here. So this is 1. But now this is diverted at these 2 points. So this will become 0 and this 0 transfer here also. अब देखो 1.0 is 0, लेकिन उसका कॉम्प्लीमेंट क्या बनेगा? 1. सेम वे 0.1 is 0, लेकिन उसका कॉम्प्लीमेंट क्या बनेगा? 1. अब ये 1 यहाँ पे भी ट्रांसफर हुआ, ये यहाँ पे भी ट्रांसफर हुआ. 1.1 क्या होता है? 1 होता है, लेकिन उसका कॉम्प्लीमेंट क्या बनेगा? 0. So y2 will be 1, y3 will be 1, but y will be 0. Now you all are clear, everyone?
Yes, sir.
Yes, sir.
Pakka? Any difficulty?
Yes,
Just
sir.
check once. Check once. Your EMI is done, na everyone? Students,
Yes, sir.
EMI हो गया है ना आपका? Okay, great. So I hope the logic gates wala part is clear. What we have done till now, I explained you the semiconductor, types of semiconductor, how PN junction form, okay, what is the forward biasing, what is the reverse biasing, and then I explained you about the logic gates. Now, based on that knowledge, we can move ahead. Okay, but before that, tell me, students, in EMI, you had studied something about induced EMF. Am I right? And the equation of EMF is given by what? It is given by E naught multiplied by sine omega t. Do you remember that?
Yes,
Students, have
sir.
you studied this? Okay. What is E naught? Anyone know what is E naught stands for?
Peak value of EMF.
Very good. This is the peak value of EMF. And E is the, what is E? E is known as instantaneous value of EMF. What is the meaning of instantaneous? EMF at time t. EMF at time t is known as instantaneous EMF. आया समझ में? अगर हम इसका ग्राफ प्लॉटिंग करें, the graph will be like this. Now tell me, student, what type of graph it is? What is the nature of the graph?
Sinusoidal.
Very good. How to identify? If the graph starts from the origin, then it is known as a sine wave. Okay, then it is known as sine wave, and it is known as sinusoidal waveform. Are you clear? What is ERMS then? How do we calculate ERMS?
E
Okay, देखो
naught by
यहाँ
upon root 2.
the peak value which I denote by E naught. Yeah, ERMS कैसे calculate करते हैं? E naught divided by root 2. Okay, the reciprocal of root 2 is what? 0.707 of E naught. So percentage wise देखा जाए तो it is 70.7% of E naught. तो ERMS कितना होगा? 70.7% of E naught. तो अगर हमें ग्राफ पे इसे रिप्रेजेंट करना हो तो देखो ये E naught है तो ERMS will be somewhere over here. This is ERMS. मुझे बताना जो रेड कलर में मैंने वेवफॉर्म ड्रॉ किया है वो AC है या DC है? द रेड कलर वेवफॉर्म इज AC और DC?
AC.
AC.
What is the difference between AC and DC? What is the difference?
Magnitude and direction don't change.
Okay.
DC, they change in AC.
Okay, okay. But what is the prime difference? Anyone know?
AC has dual polarity.
Okay, AC will have certain frequency, but DC will have zero frequency. याद रखना. You are getting, okay. We draw AC waveform like this, na? So I can measure the time period for this, and hence I can measure the frequency which is given by 1 over T. But when I draw DC waveform, the DC waveform is like this. This is a time axis. So DC has got no frequency. So the signal having zero frequency is known as DC. And the signal having certain frequency is known as what? AC. Are you all clear? Students, are you all clear? तो मुझे बताना यहाँ पे जो मैंने रेड कलर में वेवफॉर्म ड्रॉ किया है वो कौन सा है? AC है या DC है?
AC.
Students, the red color waveform is AC or DC? Respond, please. What's the problem with you all? Why don't you answer? The red color waveform
AC.
is AC. It is AC, and that yellow dotted line is what? That yellow dotted line is it DC? Student, yes or no? तो जो AC
Yes.
का DC पार्ट है उसे कहते हैं RMS. Is clear? AC का जो हमने DC कंपोनेंट फाइंड आउट किया है उसे हम क्या कहते हैं, उसकी RMS वैल्यू. Are you clear? Okay, the way we operated for EMF, same way we can operate for current also. What will be the formula for IRMS? It will be I naught divided by root 2. That means again 0.707 times of I naught, which you can also write 70.7%, 70.7% of its maximum value. You are getting okay. So once again, if you draw the AC waveform, you can see that this is the highest value of current I naught. You are getting, लेकिन इसी AC के ऊपर जब हम एक DC कंपोनेंट को ड्रॉ करेंगे, DC कंपोनेंट को ड्रॉ करेंगे, उसे हम क्या कहेंगे, उसकी RMS वैल्यू. Are you clear? Students, are you clear with the explanation? Pakka? Okay. Now let's learn one more point. Suppose we have 10 volt DC supply. So the symbol is like this. Okay, सर्कल के अंदर एक स्ट्रेट लाइन ड्रॉ करो. स्ट्रेट लाइन का मतलब क्या हुआ, नो फ्रीक्वेंसी. सो इसे कहते हैं 10 वोल्ट का डीसी. लेकिन अगर हम 10 वोल्ट एसी की बात करें तो यू विल रिप्रेजेंट लाइक दिस. नाउ आंसर माय क्वेश्चन, कि जब मैं कहता हूं कि मेरे पास 10 वोल्ट का एसी सप्लाई है, आई एम रिपीटिंग, मेरे पास 10 वोल्ट का एसी सप्लाई है, तो बताइए बच्चों कि एग्जैक्ट हम कौन से वैल्यू की बात कर रहे हैं. हम उसके आरएमएस की बात कर रहे हैं या फिर हम उसके पीक की बात कर रहे हैं. व्हेन आई हैव 10 वोल्ट का एसी,
RMS.
ओके, वेरी गुड, वेरी गुड. तो हमेशा याद रखना कि जब आपको एसी का स्पेसिफिकेशन दिया जाता है तो याद रखना ये उसकी आरएमएस वैल्यू होती है. आर यू क्लियर? सो इवन इफ आई से दैट आई एम हैविंग 10 एम्पियर का एसी करंट, तो याद रखना ये उसकी आरएमएस वैल्यू है. knowing the RMS value, you can calculate its peak value. Are you clear? Students, are you all clear?
Yes, sir.
Yes, sir.
Any difficulty? Just revise this slide once, because this knowledge is required for further discussion. Everyone, is it clear? Any difficulty? Now tell me how many components you have studied in EMI? How many components you have studied in EMI?
3.
3 components. This one is resistor, this one is inductor, this one is capacitor. Okay, the first component is known as what? It is known as a resistor. What the second component is known as? It is known as inductor. And the third component is known as what? It is known as capacitor. Resistor will have certain resistance R. Okay, so resistor will have certain resistance which is denoted by R. Then what about inductor? Inductor will have, anyone know? It will have inductive reactance, and capacitor will have capacitive reactance. Okay, now student tell me, just a minute, capacitive reactance. Inductive reactance is denoted by which letter? Anyone know?
XL.
Very nice. And what about capacitive reactance?
XC.
XC. What's the formula for XL? Anyone know?
Omega L.
Very good. What about XC?
1 upon omega C.
Very good. What is the formula for omega?
2 pi F.
2 pi FL. And what about this? This is 1 over 2 pi FC. Okay. All three will have the same unit, that is ohm. For this also the unit is ohm. For this also the unit is ohm. That means they are a kind of opposition to the flow of current. Are you clear? Students, are you all clear?
Yes, sir.
Yes. Okay. Now see the fun. We will discuss on the next case. What is the difference between AC and DC? Students, what is the difference between AC and DC?
AC has frequency and DC has zero frequency.
Okay, very good. So let's talk about XL. XL is given by what? It is given by 2 pi FL. Okay, suppose we have DC supply and other case we have AC supply. For DC supply, what will be the value of XL?
0.
Zero.
Okay, so DC क्या है? The one having zero frequency. So XL will become 0. और AC क्या होता है? Whose frequency is greater than 0. Okay, so that means the value of XL will be non-zero. The value of XL will be non-zero. Let us talk about XC. What is the formula for XC, everyone? It is 1 over 2 pi F multiplied by C. अब देखो यहाँ पे frequency 0 है, इसका मतलब क्या हुआ?
Infinity.
हाँ, very good. मतलब XC का वैल्यू क्या होगा? It tends to infinity. Okay, what is the meaning of tends to infinity? It is close to infinity. But what about AC? For AC, there will be certain frequency, ना? So XC will have certain non-zero value. Okay, अब देखो, अगर infinite opposition किसी को मिले, तो can current flow through it? बच्चों, अगर किसी को infinite opposition मिलता है,
No.
तो current उस रास्ते जाएगा क्या?
No, no, no.
बोलो बोलो। तो कैपेसिटर में से डीसी करंट फ्लो हो सकता है क्या? कैपेसिटर में से डीसी करंट फ्लो हो सकता है या नहीं हो सकता?
No.
No.
नहीं हो सकता। तो इसका मतलब क्या हुआ? कैपेसिटर विल ब्लॉक विथ सिग्नल, कैपेसिटर विल ब्लॉक विथ सिग्नल डीसी
DC.
and it will allow only AC. Just remember this point of capacitor. Okay, I'm clarifying all your basics. अगर ये समझ में आ जाते हैं तो complex circuits will also become easy for you all. So remember, capacitor is the one who will block the DC signal and it will allow only AC signal. You are getting? Students?
Yes, sir.
ये बताना, कॉइल में से कौन सा करंट इजीली फ्लो हो सकता है? कॉइल में से कौन सा करंट इजीली फ्लो होगा?
AC.
कॉइल इज ऑफरिंग जीरो रेजिस्टेंस या जीरो अपोजिशन टू विच सिग्नल? डीसी सिग्नल ना बच्चों?
Yeah, DC.
Tired of what or not interested? Have you studied the application of coil? कौन से सर्किट में आपने कॉइल को यूज किया है? स्टूडेंट्स, ट्रांसफार्मर में क्या आपने कॉइल को यूज किया है? स्टूडेंट, yes or no?
Yes, sir. Yeah,
How
yeah,
many
yes.
types of transformer you had studied?
2.
कौन से?
Step up and step down.
Step up and step down. Remember all these points, huh? Because in further discussion we need them. What is the difference between step up and step down?
Step up
Yes.
increases the
What is the difference
voltage.
between step up and step down?
In step up, the secondary voltage increases.
Okay, so if you want to increase the voltage, this is the primary coil, P1 and P2. These are the secondary terminals, S1 and S2. Okay, tell me, if I compare the number of turns of primary with secondary, which one is greater?
Secondary.
Secondary.
Okay, so if I compare the input voltage with the output voltage will be higher, but the current will be lowered. Okay, but remember the input power will be exactly equal to the output power. तो ट्रांसफॉर्मर का मतलब ही क्या है? What is the meaning of a transformer? It is a transfer of power. याद रखना, ट्रांसफॉर्मर का मतलब क्या है? ट्रांसफर ऑफ पावर आइडियली बाय 100%। तो जो भी पावर आप इनपुट को फीड करोगे वो किससे जानी चाहिए? सेकेंडरी को। ओके, व्हाट इज द फॉर्मूला फॉर पावर? पावर इज गिवन बाय वोल्टेज इनटू करंट। ओके, नाउ आंसर माय नेक्स्ट क्वेश्चन एवरीवन, के ट्रांसफॉर्मर विल satisfy ohms law or not? Student, transformer will satisfy the ohms law or not? It is ohmic device या non ohmic device? बच्चों, it's a ohmic device या non ohmic device? Just look at the relation between the current and voltage and then you can decide. Hello बच्चों,
Non-ohmic device.
non ohmic na, see the look at the relation na, they are inversely proportional. Voltage is increasing but the current is decreasing, so it's a non ohmic device. याद रखना, such MCQs can also be asked in your board examination. Okay, so this one is a non ohmic device. अब यहाँ पे अगर आप देखो, if I compare the number of turns are decreasing. अगर number of turns decrease हुए तो voltage भी decrease होगा. Okay, लेकिन current will increase. कुछ भी हो, power should remain same. Input power must be equals to output power. Can you tell me कि in your daily life स्टेप डाउन ट्रांसफार्मर कहाँ पे यूज होता है?
Home appliances.
Mobile
Mobile.
charger.
Mobile.
हाँ, मोबाइल में देखो, आपके मोबाइल में एक एडाप्टर है, चार्जिंग कॉर्ड के साथ एक एडाप्टर दिया हुआ है, जिससे डिसाइड होता है ना कि फास्ट चार्जिंग होगा या नॉर्मल चार्जिंग होगा. यू नो दैट ना, जो आप सॉकेट के अंदर घुसाते हो, दैट इज द एडाप्टर. आर यू क्लियर? सो द पॉइंट टू बी नोटेड कि वो जो एडाप्टर है उसके अंदर एक ट्रांसफार्मर कॉइल होती है. ओके, आपके घर में कितना वोल्टेज आता है? आपके घरों में
220.
कितना वोल्टेज आता है? आपके घरों में आने वाला वोल्टेज कितना है? 220 वोल्ट
220.
विद द फ्रीक्वेंसी ऑफ 50 इन इंडिया. दूसरे कंट्रीज में ये फ्रीक्वेंसी अलग होती है. सो इन इंडिया इट इज 220 वोल्ट एंड 50 हर्ट्ज. यू आर गेटिंग? But my mobile don't require 220 volt, so I needs to reduce the voltage. So for that, what I will use? I will use a transformer. Are you all clear?
Yes.
Students, are you all clear? Okay.
Yes.
But there are some components you can say, like CRT. CRT stands for what? Cathode ray tube. Okay, so CRT and all, they require very high voltage for their operation. What do you mean by very high voltage? They require voltage in the range of kilovolt. So tell me, in that case, which transformer you will use?
Step up.
Step up.
Up transformer. Are you all clear? Students, are you all clear?
Yes.
Yes, sir.
Yes. Okay, very good. So remember one ratio over here, that's something known as a transformation ratio. Have you studied this ratio? Transformation ratio? Yes or no? The formula is N2 divided by N1, which is given by V2 over V1, which is given by I1 over I2, because there is inverse relation. Now tell me, for step up, the value of R will be greater than 1 or less than 1? Just look at the formula, N2 and N1. Step up mein N2 is greater than N1, na? So numerator is bigger than denominator, so R will be greater than 1. And step down mein R will be less than 1. Are you all clear? Students?
Yes.
लैमिंगटन रोड गए हो?
Yes.
घूमने गए होंगे ना? So you must have seen the electronic market over there. So if you go and ask them for a transformer, they may ask you for the value of R. Okay, so don't give them a shocking reaction. That R is known as what? Transformation ratio. You are getting? How do we calculate the efficiency of a transformer? Students, how to calculate
Output power upon input power.
Very good. Output power. Efficiency is always calculated as output over input. So it is output power divided by input power. Okay, power is calculated as V2 multiplied by I2 divided by V1 multiplied by I1. If you want percentage efficiency, na, then you simply multiply this ratio by 100. Are you clear?
Yes.
Students, any difficulty? Now tell me, the supply which comes to your house is AC or DC?
AC.
AC.
Okay, supply which comes to your house is AC supply. Okay, but your most of the household appliances, they require DC supply. Okay, so for that we will use one network, and that network is known as rectifier circuit. So what is the function of rectifier circuit? It convert your AC signal to DC signal. If someone asks you what is AC, so don't say it is alternating current, and DC don't say it is direct current. You should say it's a alternating signal या फिर direct signal. Because when I say it is AC, it can be alternating current also, it can be alternating voltage also. Same way, when I say DC, it can be alternating voltage also, sorry, it may be direct voltage also or direct current also. So what is the proper term? AC is the alternating signal, DC is the direct signal. Are you all clear? Students?
Yes, sir.
Pakka? So what is the function of rectifier circuit? Tell me, what is the function of rectifier circuit?
Conversion.
To convert alternating signal
AC
to
signal.
direct. Okay, there are total 3 types of rectifier circuit we have. Number 1 is half wave rectifier. Half wave rectifier. What is number 2? Anyone know? It is full wave rectifier. It is full wave rectifier. And what is number 3? Number 3 is a bridge rectifier. Yaad rakhna. What is number 3? Number 3 is a bridge rectifier. Are you all getting? In your syllabus, you have only half wave and full wave rectifier. Okay. So remember, in the next segment, we have to discuss the types of rectifier circuit. And we have total 3 types of rectifier: half wave, full wave, and bridge. But in your syllabus, you have to deal with only half wave and full wave. What is the function of rectifiers? To convert alternating signal to direct signal. Are you clear? इनका यूज कहीं पे देखा है आप लोगों ने? कैन यू टेल मी वन एप्लीकेशन ऑफ रेक्टिफायर? स्टूडेंट्स, everyone, have you seen the application of this? Say either yes or no, that's it.
In appliances with motors, because they have DC motors.
Okay, now in your festives like Diwali, Christmas and all, okay, आप घर में lightings लगाते हो ना?
Yes.
अरे yes or no? Okay, LED का strip खरीदा होगा आपने. तो LED के strip के साथ अगर आपने notice किया है तो you will find one box like this. एक डिब्बी आती है जहाँ पे प्लग रहेगा ना आपका 2-pin सॉकेट, उसके साथ एक एडाप्टर आता है जिसमें एक बटन रहता है. उसको प्रेस करोगे ना तो पैटर्न ऑफ द लाइटिंग विल चेंज. हैव यू सीन?
Yes.
Student, yes or no? If you press this button na, the pattern of the lighting will change. Okay, so inside this box you will find transformer as well as rectifier circuit. You will find a transformer as well as a rectifier circuit. Are you all clear, students? Okay, so we'll stop for today. In the next segment, we will start with the half wave and full wave rectifier. I hope whatever we discussed today is clear for all.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Sir?
sir.
Okay, very good. So kindly revise what we have discussed today, and the next part we will continue in the next class on Wednesday. Okay.
Thank you, sir.
Yeah, revise and come. Then the next lecture will be easy for you all. Okay. Chalo. Bye all. Take care.
Thank you, sir.
Thank you, sir.